Hello everyone, today let's see what is algebra of limits. So we'll understand this concept using a theorem. Let f of x and g of x be two functions and such that limit x tends to a, f of x is equal to L, and limit x tends to a, g of x is equal to M. That's nothing but limit of function f of x at x tends to a is L, and limit of function g of x at x tends to a is M. Okay, so when this is the condition, we have 4 points here, that is limit x tends to a, f of x plus g of x, that is function f of x plus g of x, the limit will be L plus M. Okay, the limit of function x tends to a, f of x minus g of x will be L minus M. Limit x tends to a, f of x into g of x will be L into M, and limit x tends to a, f of x divided by g of x is L by M if M is not equal to 0, that is M is the denominator is not equal to 0. So we will prove these theorems, prove these points. Okay. So these are the data we get from the question. Limit x tends to a, f of x is equal to L. Limit x tends to a, g of x is equal to M. So we have limit x tends to a, f of x is equal to L. From the definition of limits, we have this. These are the interpretations. Okay. That implies for all epsilon greater than 0, there exists a positive real number, delta 1, which is greater than 0, such that mod of f of x minus L is less than epsilon by 2 whenever 0 less than x minus a less than delta 1. We are taking this as delta 1 and delta 2 because we have two functions, that's why. Okay, so we have limit x tends to a, g of x is equal to M. That implies what? For all epsilon greater than 0, there exists a positive real number, delta 2 greater than 0, such that mod of g of x minus M is less than epsilon by 2 whenever 0 less than mod of x minus a less than delta 2. So this I am taking it as equation 1 and this I am taking it as equation 2. Okay, we know that let delta is taken as a minimum of delta 1 and delta 2. So we can replace this delta 1 and delta 2 by delta now. So from 1 and 2, what are we having from 1 and 2? Mod of f of x minus L, mod of f of x minus L less than epsilon by 2, and mod of g of x minus M less than epsilon by 2 whenever 0 less than x minus a, mod of x minus a less than, this was delta 1 and delta 2, we are taking it as delta now. Okay, so now to prove the first thing, that is what? F of x plus g of x is equal to limit x tends to a, f of x plus g of x is equal to L plus M, right? First proof. So let's see how to prove that. So I am taking f of x plus g of x. We have function minus the limit. So f of x plus g of x minus the limit of f of x was L, limit of g of x was M. So I'll take this to prove. Mod of f of x plus g of x minus L plus M minus of L plus M. This, instead of one function, I'm taking two functions. Instead of one limit, I'm taking two limits of these two. Okay, I want to prove f of x plus g of x, L plus M. That's why I'm taking positive here. Okay, less than epsilon. 0 less than mod of x minus a less than delta is the condition we have. Consider this one. We are taking this one. We have considered mod of f of x plus g of x less than, minus L plus M is equal to, I am splitting this function and limits inside here. I'm jumbling it up. Okay, that is f of x minus L, I'll club together, plus g of x minus M. Plus into minus is minus. Okay, so that is g of x minus M. I am shuffling these functions and limits here. So I got this. Now I am breaking this or separating this mod. So I'm taking it as, since I'm separating this mod, I have to write this equality to be less than. Okay, so less than mod of f of x minus L plus mod of g of x minus M. We know that mod of f of x minus L is what? Epsilon by 2. Mod of g of x minus M is what? Epsilon by 2. So the condition is 0 less than mod of x minus a less than delta. So adding this up, what do we get? 2 epsilon divided by 2. That means 2 and 2 gets cancelled and we'll have less than epsilon. So we have this is less than epsilon. See, if this is less than epsilon, we can conclude that limit x tends to a, f of x plus g of x is equal to, we'll bring this to the other side, L plus M. Okay, so second one also you can prove in the same way. But here, see, I have written again the data because they will not sometimes ask everything together. That is theorem points 1, 2, 3, 4 all together. They may not ask to prove. So what do you have to do? You have to prove either 1 or 2 which is being mentioned in the question, right? So when in that case, what you have to do is you have to write the data again. If they've asked everything together, if you write the data once, it is enough. Only the proof, that is, say this part, consider. Only this part if you write, it's more than enough because you've already mentioned all these data prior itself, right? Say here, see, you have already mentioned it here, starting of the theorem. So you don't have to write that again. Okay. So if it is separately asked, you have to write this way again. You have to write the data, what is data being given in the question. Again, I have elaborated that using the definition of limit of a function. Again, from equation 1 and 2, what happened, I have written. Now to prove the next one, that is f of x minus g of x minus limit. What was the limit? L of f of x. This is limit of g of x is m. So we had to prove f of x minus g of x, right? So I have written this way, f of x minus g of x minus L minus m, which is less than epsilon. If we prove, we can say that the limit x tends to a, f of x minus g of x is equal to L minus m. Okay, in order to prove that, what we have to do, we have mod f of x minus g of x minus L minus m, and I am shuffling as we did for the previous one, f of x minus L, f of x minus L minus g of x, minus into minus plus m. Now I am segregating these two terms as f of x minus L. I am taking minus common outside. I am writing it as g of x minus, this is minus into minus becomes plus, right, again. So if I take minus common out from this plus, this becomes minus m. Okay, so when I'm segregating the mod or separating the mod, what happens for the equality? It becomes less than, right? So now mod of f of x minus L, if I take this minus inside this mod, that will vanish, right? Yes, since it is mod, we don't have that minus sign coming out, right? So I'll take here it as plus, and mod of minus of g of x minus m, that can be written as mod of g of x minus m, right? That minus vanishes if I take mod from here, right? Taking outside plus. Okay, so what happens now? This is less than epsilon by 2. This is also less than epsilon by 2. We know from the definition what we have got from the data given, right? So we have 2 epsilon by 2. 2 and 2 gets cancelled and it will become epsilon. Under this condition, 0 less than mod of x minus a less than epsilon. Therefore, what can you conclude? Limit x tends to a, f of x minus g of x is equal to L minus m. Thank you.